time.
Yes.
Everybody's here, but Jerry is not.
Everybody's not here, speak up.
Here I am. All right. I just fly in from off the side there. Scott, thank you for mentioning the Magnahelic gauge. The Magnahelic gauge. So it is a gauge that can be used. We use it in HVAC, and you could use it in fuel gas. So I quickly went out and I got an image. I'll show you. Here it is right here. Magnahelic. It actually measures inches of water or increments of an inch of water. We use this for like low pressure duct work. You can buy different ranges that you can actually use this gauge just like a manometer. This is called a U-tube manometer in the same fashion. Right? We use gauges in the real world, you know, unless you're doing all kinds of different things with different fluids. You'll use different fluids to measure different systems. But in gas piping, it's pretty simple. So let's continue our discussion here. Oh, by the way, where is she? Hey, Rashana, did you get that calculation to work?
I did not. I don't know what I'm doing. I put in 1 divided by 62.4 divided by 1728.
And then that's not going to work. Yeah, that will not work. Do this. Are you ready?
Yes.
Take this parenthesis right here. Just do this right now. Take 62.4 and divide it by 1728.
Okay.
All right.
Okay, there. I got 0.0361.
All right. So write that down or store that somewhere.
Okay.
And what you're going to do is you're going to take 1 and you're going to divide it by what you just calculated.
Okay.
1, and then put that decimal in the denominator. You'll come up with the right value.
Okay. Okay.
You better come up with the right value.
Okay. Okay, and so now you want me to apply it to the second formula?
No, just put a 1 in here. Let me write it out for you. Whatever number here.
I'm sorry, guys. I'm so sorry.
We're here to learn, ladies and gentlemen. So if I say 1 divided by, what was that number that you got? 0. What?
0361.
0 what?
0.0361.
Yeah.
0.0361?
Yes.
All right, so if you take 1 and divide it by 0.0361, what did you come up with?
Okay, 27.7. There we go.
Bada bing!
Thank you.
Goodness, we got it to work. There we go.
Thank you.
All right, you're welcome. So that works. I'm going to leave that there because somebody else might ask me that question.
Thank you.
I better save this. All right, fantastic. Let's move on. Enough of this. I think we beat up the pressure enough. You'll thank me when we get into the fuel gas piping, I promise you, or you'll thank yourself for going through this. All right, let me get my cursor out here and we're going to keep moving on. All right, so again, take a look at this. Whenever the installer sets this up, we're given manufacturer's information, manifold pressure right here. I need at least 3.5 inches water column pressure at the manifold. All right, that's what it's designed for. We also have a maximum permissible gas pressure. If you're designing the system, which I don't know if you've ever done this, if you've ever installed gas piping, I don't know. If you did, you will check the pressures. You will verify the pressures because this furnace says, hey, we will not allow a pressure over the following right here, 10.5 inches water column for natural gas. You will not exceed that pressure supplied to my furnace of more than 10.5 inches water column. Now that begs the question, right, Doug? How am I going to measure that? Well, I'm going to measure that right at the gas valve in the furnace. There's usually a port inside the gas valve. It's like an 1/8 inch female pipe thread that you actually put a barb on and you put your hose on it. You can measure the gas pressure right at the gas valve for the gas supply coming into the furnace. You know, that's one way to measure the gas pressure, okay? If it's propane, ladies and gentlemen, which this furnace has the ability to be converted to propane, It's 13 inches water column is the maximum pressure permitted. So if you've never read a nameplate before, this is telling not only the installer about how the system operates, it's telling you, the mechanical inspector, although we're not there checking pressures, don't get me wrong here. We're just looking at the piping, is it installed right, things of that nature. But I got to tell you, if you want to be a good inspector out there and you want to be respected and trusted, you're going to do the right thing. You're going to fortify your education. You're going to learn as much as you can about that specific discipline. And this is where to learn, right here. All right, moving on. I think we're done with this. Fantastic. Let's get out of here. All right, we already went over that. Appliances in rooms. Here's your clearances for service. You remember what we read in the code? I need 30 inches of depth. Right? I got to be at least 30 inches high or as high as the appliance. I got to be as wide as 30 inches or as wide as the appliance. That's not only for furnaces, but, you know, boilers, things of that nature. Look at a three-dimensional kind of a, I don't want to say it's a cube. Yeah, maybe it's a cube. Could be extruded higher if the furnace or the boiler is higher. But this is what we need for proper clearance for servicing, maintaining, and replacing and repairing components accordingly. Hey, I got a question for you. Furnace is installed in an attic with a passageway 4 feet in height is permitted to be located. Okay, so I've got a passageway installed in the attic. I've got 4 feet of height from the passageway to the rafter. What is my maximum distance that I could be from the attic access to the appliance? Is it 5 feet, 10 feet, 20 feet, or 50 feet?
C, 20.
C, 20. Remember, if I have 6 feet or more, then I can go how far?
50.
50. That's exception number 2, remember? Right? But in general, yep, you're right. 20 feet right here. There's your code section. Inspectors, if you're looking at things in attics, you better take a look at this code section. You may have to cite somebody down the line. Sometimes they'll get further than 20 feet. And always check for the light that they call the luminaire and the receptacle too. Fantastic. We're moving along. Oh, you have a checklist here. Little checklist here of some things here with code sections regarding access, passageway, things of that nature. Let's talk about clearance inspection. I have some code sections here in front of you on the screen. Look at what this gives us here. I have chapter 24 referenced here, 2409 for clearance reduction. And I've got some chapter 14 and chapter 13 sections for clearances from combustible construction. So we're going to take this in a step-by-step fashion here. When you go out in the field and you look at heating appliances primarily, we need to find out where they're located. Are they in the garage? Are they in the attic? Are they in a room? Are they in a crawl space? You determine the type of mechanical appliance. What is it? Is it a boiler? Is it a furnace? Is it a water heater? Is it an air handler? We need to read the required clearances. It's either on the label, ladies and gentlemen, or in the manufacturer's installation instructions. Clearances to what? Clearances to combustible materials. You need to measure this stuff. Or if you have a good eyeball, you can do it. Here it is right here. Take a look at this. So this is a furnace. It's an upflow forced air furnace. What we're talking about is, this is called side clearance. You measure perpendicular from the furnace casing itself to any combustible material. All right, I'll ask you a question now. If I measure this furnace, maybe it's in a room, perhaps a large room, or maybe a finished basement area, and I measure from the side to maybe drywall. Is drywall a combustible material? Let me put it to you in another way. Is drywall considered a combustible material according to the mechanical code?
No.
No, that's what you use for fire rating.
Come on, somebody else weigh in. We just can't have a couple people. Let me know. Carla, Jamie, Mr. Johnson,
No.
Antonio, weigh in.
My
Yes or
vote is
no?
no.
No.
I like Francisco's answer.
What was Francisco? Did you give me some wishy-washy answer, or did you give me a good answer?
Good answer.
Yes, that's what we normally use for fire rating assembly, drywall, always, you know,
Yeah. Okay.
garages, any
I'm with
dwelling units.
Well, let me tell you how this works. In the mechanical code, not only the residential code, but the commercial code and the fuel gas code, drywall is a combustible material, period. End of story.
Okay,
Okay, so we need to look at drywall as a combustible material. When we measure clearances from appliances to those materials, okay? I know we use it for fire resistance ratings and things of that nature, but drywall, wood construction, things of that nature, there's a test. You may want to write this down. It's called ASTM E136, American Society for Testing of Materials E136. And if you got a Google by you, Google it. You'll see exactly what this test. It will burn materials and look at their flammability and their reduction in volume. That's the true test for combustible materials. So
well,
this is what we're
reality,
looking
everything
at here.
burned, right? In
Pardon me?
reality, everything burned. You know, it's just the time that it's gonna take to burn. That's what we after.
Okay, so we're just looking at things that are classified as combustible materials. So in other words, we're looking for clearances here, right, Francisco? We don't want the furnace to be too close to a combustible material to give off maybe radiation or by convection, a heating effect on those materials to maybe cause something to maybe combust, maybe get too hot, right? The manufacturer will give you all these clearances from the top, the back, the side, the front, even the floor, which isn't even shown here. So when we look at this, we say to ourselves, well, gee, can I possibly reduce the clearance that the manufacturer gives me? The answer is yes and maybe. The answer is yes, you can, if the manufacturer will allow a clearance reduction method according to the mechanical code. In which case they do. If you read enough manufacturer's installation instructions, you will find some of this language that you can reduce the clearances. If these are listed appliances, you know what a listed appliance is? That means that it's been tested in a nationally recognized testing laboratory like UL or CSA or ETL, and it's been tested for that particular function in operation as a gas furnace, a boiler. So the appliances have to be listed and they all come equipped with a label. So let me show you, there's a table in chapter 13 here, and it allows you to build prescriptive assemblies, maybe on a wall or a ceiling, to reduce clearances. And I'm going to give you an application here in a second. Here's the table in chapter 13. You also have a table just like it in chapter 24. What type of fuel source would I be looking for if I utilize this table for a furnace? What type of fuel would be
Oil.
the source? What is it?
Oil.
Oil. Oil. Yeah, it's other than gas. Yeah, right on. I'm with you. Other than gas, man. If it was gas, I'm in 24. Right? So let's say it's oil. And I figured, well, you know what? Let me see if I can understand this table here. The top over here is given in the manufacturer's recommended clearances. You see 36, 18, 12, 9, and 6. Manufacturer. Within each manufacturer clearance, right? I have two subcolumns here. Subcolumn 1, subcolumn 2. Subcolumn 1 is going to be above the appliance. In other words, I measure from the top of the appliance upward towards the ceiling. If I wanted to build a ceiling assembly, I would use column number 1. If I wanted to build like a wall assembly, a vertical assembly on a wall, I would use column number 2. Okay, sides and rear. So in other words, I measure from the side or the rear to a vertical combustible material or assembly. All right, so that's how you apply this. Now, let me show you how this is applied. There's a picture here, right here. If this is my appliance and the manufacturer says, yes, you can reduce the clearance to combustibles. We know that gypsum wallboard is considered a combustible material as shown here as well. If the manufacturer says, hey, for my boiler, you will have 36 inches from the rear of the boiler to any combustible material. Here's how this works. In fact, this actually happened to me when I was in business about 25 years ago. I sent 2 apprentices to change out a boiler in a basement. It was a residential boiler, simple little job, right? They pulled the old boiler out. We put a brand new Wheel McLean boiler in its place. My guys put it too close to the wall though. Inspector came out and it didn't pass inspection because they were less than 36 inches. So what happened here? This code, this standard that you see here, this table has been around. Let me give you a little bit of history here. This has been around longer than the ICC's been in existence. This comes from NFPA 31. I think it's in NFPA 211, if I'm not mistaken. But these standards have had this table in them for decades, ladies and gentlemen, even before the ICC even gotten into business, right? I knew this table existed many years ago, so what I did is I applied this exact table. Crazy how this stuff comes up. I had some sheet metal in my shop. I made up 2 pieces of sheet metal, 24 gauge sheet metal, and we sandwiched mineral wool insulation in the middle, right? We stood it off with non-metallic little pieces of pipe, like copper pipe, right? Or copper tubing. We stood that off, so we had a 1-inch air gap, right? What are we doing here? We're actually using this, people call it a heat shield, if you will. It's really not. We're actually taking this and creating a cavity from the combustible wall surface to this metallic assembly that we just built, right? Think about it. Whenever my boiler heats up, it's going to generate heat, right? And by convection, like we saw on that little room heater, hot air is going to rise in the room, isn't it? When the hot air rises, right? The hot air rises by convection, the cooler air is going to drop. What's going to happen? It's going to make its way up around the backside of this assembly and cool the combustible surface down by convection. That's why we need a 1-inch air gap on the sides and the bottom of this particular assembly, because it's going to cool the combustible assembly. Thus, we can get a reduced clearance to combustible surfaces. Now, when you measure this, I see people get this wrong all the time. You take one measurement, measure from the back or the side of your appliance to the combustible surface. You never measure from the appliance to your assembly. It's always from the appliance to the combustible surface, right? Always, that never changes. Now, the manufacturer called for 36 inches. If we went with this type of an assembly, how much can I reduce this clearance to? In other words, how close can I get my boiler to the wall? Let's find out. I'm going to apply the table. Simple enough, right? Here it is. Manufacturer says 36 inches. I go down to column 2, sides or rear. I intersect it with this. It looks like 12 inches based upon the assembly that's been built on the wall. 1-inch glass fiber, mineral wool bats sandwiched between 2 sheets of galvanized sheet steel. What gauge? 24 gauge. There it is right there. I can be as close as 12 inches measured from the back of the appliance to the combustible surface from the wall accordingly, if I place and build this assembly on the wall, just like you see it here. But the manufacturer must allow clearance reduction methods. When this happened to me, it was an oil-fired boiler, okay? It was in a rural area. I contacted the building official at the time. I actually drew up my picture. It was similar to this here because I wanted to get an approval before we built it on the wall, right? And I did. It was back when we faxed a lot. Remember that thermal paper in our fax machines? I don't know if you remember that. Maybe you do. We had fax machines, so I faxed it over to the building official, and he faxed it back. Yeah, this is good, Jerry. Have your guys build it. We'll be out on Monday. We built it Monday morning. They came out, passed with flying colors. The manufacturer actually allowed the clearance reduction method based upon the standard. I believe it was, it was NFPA 31 at the time. And now we see it in the modern codes. Does that help? So in other words, if you're an inspector and you go out and you see some of this stuff, you know what? You have a solution. Just don't go out there and say, oh, it fails miserably. You got to move that thing out of there. You know, put on your education hat. Say, you know what? Maybe the manufacturer would allow a clearance reduction method. You know, they have materials now that you can actually adhere to the wall surface. They're listed, clearance reduction panels. They're cementitious that you could actually fasten to the walls. All right, so understand that that exists, ladies and gentlemen. And there's also a table just like it in chapter 24. All right. Oh, let me go on, and we already checked that. Here's where we are right here. Step 4, if you follow along in your workbook, you'll come to step 4. This is what we talked about initially. Hey, can I really put an appliance in the garage? The answer is yes, you can, but you need to elevate the source of ignition. When I look at chapter 13, again, I'm looking at maybe an oil-fired appliance, perhaps, being located in a garage. When I look at this, sometimes what you'll see here is you'll see a mechanical room built, you know, adjacent to the garage area. Same finished floor elevation, right? From the garage into my mechanical room. Be aware that doors, that doesn't even matter, right? If it's adjacent to the mechanical room is adjacent to the garage finished floor, you still need to elevate your appliances. However, there's an exception. I'll talk about that in a second here. Number 1, we got to elevate the ignition source, maybe of the furnace here, perhaps. We need to get it at least 18 inches above finished floor. I guess I'll open it up for discussion now. What do you think a source of ignition is on a furnace like that, a forced air upflow furnace? What could possibly be the source of ignition?
Natural gas.
Well, yeah, Don, natural gas alone would not be the source of ignition. Give me, for vapors,
Control switch.
igniter. Yeah, igniter. What else?
Oh, source. Oh, I see what you're saying. Any fumes, you know, could be like automobile gasoline, spilled gasoline, that type of thing.
Wherever it's sparked.
Oh, it's a pilot lighter.
We're looking at the appliance only. Just look at that furnace. Think about how a furnace works. Okay, I agree with you, like a spark igniter to ignite gas at the manifold. What else?
A pilot flame?
The pilot light, yeah.
Yeah, the little spark igniter. How about a glow coil? We don't have standing pilots anymore, but we used to.
You've got blower motors that cause a spark.
Stuff like that. So that may be an option there. So yeah, if you have that, right? What else? Glow coils. What else? What else?
The internal fan could cause sparks.
You mean the fan motor, Jason?
Yes, fan motor. Yes.
The fan motor. And give me something else, Jason. What turns the fan on and off?
The electricity, the switch.
Your
The
contact.
switch called contact relay,
Contact.
right? And it's
That's right.
yeah. So if you don't know anything about mechanical appliances, ladies and gentlemen, let me help you. In the forced air furnace, this little bottom compartment here, that's the blower compartment. In that blower compartment, you'll see probably like printed circuit boards, relays attached to the printed circuit board, fan motors in here, right? Those are all sources of ignition. They have to be elevated. All right. Now, there's a technology that came out for water heaters about 25 years ago. And all residential and many commercial water heaters are being manufactured with this technology now. It's called the Flammable Vapor Ignition Resistant System. And this, you can mount the water heaters directly on the finished floor. You don't have to elevate them. It actually senses, it's got sensors, these little click-ons, if you will, around the ventilated area on the bottom of the water heaters where the combustion air gets taken into. Once it senses that there's ignition or combustion, it automatically shuts down the aquastat on the water heater. It's really good, quick technology, very safe technology. And it's labeled right on the water heaters that the water heaters are equipped with this and you do not need to elevate them. But you know what? If I wanted to, could I elevate the water heater if I wanted to?
Yes.
Absolutely. I can always exceed the code, you know? So there you have it. Now pay attention to this. This is for like oil here primarily because I'm in chapter 13. You'll find another section just like it in chapter 24 if you have natural gas or propane. Always keep that in mind. Look at your fuel source and then say, am I really in chapter 13? I should be in chapter 14, things of that nature. Let's talk about garages. Let's talk about appliances. We need to protect our appliances, whether it's a condensing unit, an air conditioning condensing unit, a furnace, a boiler. Take a look at this here. Say I got a condominium association, right? I know condominium is not in our building code. Maybe it's like a series of townhouses connected together, right? Multi-dwelling units, right? All connected together. And the only space that I have as a mechanical contractor to put the air conditioning condensing unit is right here. You follow what I'm saying? You have to protect the appliances from vehicle damage. In other words, you don't have to provide things that'll protect it from a 35-mile-an-hour crash. I mean, we're just talking a little bit of a bumpy here. You know what I'm talking about? So we don't wreck the thing. And you know what I'm talking? Let me give you an example. How's this? If I have a garage, ladies and gentlemen, ultimately we just saw that we had to elevate our ignition source. We say, okay, let's say that this was elevated and my ignition source was way up here, over 18 inches. We're cool, right? But look at this right here. Would you agree with me that this unit heater would be okay being mounted up on the rafters or the trusses like that? The trusses and the rafter are designed to carry the load. There's no doubt about that. But wouldn't you agree with me that the vehicle could pass easily underneath this gas unit heater or this oil-fired heater, right? Except the furnace is fair game, right? The furnace is fair game. So I go to this section here and I say, okay, appliances shall not be installed in a location subject to vehicle damage except where protected by approved barriers. I'm excited because I see an italicized word called approved. I could find that in definitions. If you have a code book, somebody go look that up. Tell me what approved means, unless you already know. What does approved mean? Does it tell me exactly what I need to put here to protect the furnace?
By the ASJ.
Yeah, you're right. It's by the code official, approved by the code official. The code official says whatever you're going to do is okay. Well, that kind of leaves me hanging. I don't know. Help me understand. What would you put, I don't know, in front of the furnace to protect it from vehicle impact or vehicle damage by the vehicle? Any idea? It doesn't tell us.
No.
A what?
A bollard.
A bollard. What's a bollard?
A concrete post that's permanently placed in front of the appliance so that when the car hits it, it hits the bollard and it stops the car from running into the furnace.
Well, yeah, that might be one thing, but Jamie, follow along with me. Are you ready? It says approved barriers. So I'm going to make everybody in this virtual classroom the code official. And I'm going to present to you my drawing of what I want to put here. And I want to see if you would say that this would be an approved barrier. Well, I go out in the evening, normally on Friday evening, and I go on to my league. It's a bowling league, and I've got an old bowling ball, and I've got some aircraft cable, and I'm going to hang that baby right from the rafter in my garage. I'm going to use a stainless steel eyelet right into my 16-pound Columbia 300 bowling ball. and call it a day. And I'm going to say, will you approve this, building official Jamie and Carla?
No,
No, I worked so hard on that drawing.
and it's so nice, but
Why
no,
not?
no, because it might damage your windshield, but it ain't gonna keep the car from going into the furnace.
You know, you come home on, after a night of bowling, or you're off of a bender or something like that, and you're coming in, that bowling ball's not going to protect the furnace, right? Right? It doesn't meet the intent of the code, right? So, yeah, I agree with you. You know, I wouldn't approve that either. You know, that's cockeyed, don't you think? Right?
So
Here's what
Gary,
we
I have a
need
question
right
for
here.
you.
Now, not
Gary.
only can you put a pipe bollard over there, but you got to be careful, right? Because you can't block the service side of a furnace or a boiler, right? Don't put the pipe bollards in, but maybe you could put a couple of pipe bollards in, maybe with some angle iron going across, like removable pieces of angle iron. We do that in commercial all the time, you know. However, look at this option. Would you approve this here if I kind of took some concrete anchors and kind of measured back and fastened a wheel barrier like this? That might be a good option. I would approve that. Put it over here.
I wouldn't.
Why wouldn't you do that? Because you can run over it, Don?
Yeah, absolutely. We have it happen 3 or 4 times a year.
Oh, did you? Yeah. And that's why this code section says it's an approved barrier. Now, personally, I would approve it. I wouldn't have a problem with that. But if you're in Don's jurisdiction, that wouldn't fly, right?
That's true.
So yeah, that's it. That's why you're the code officials out there. You have to approve it. All right, moving on. We already discussed what's on the nameplate, right? So, I mean, here's another nameplate. This is a forced air furnace. Look at this, same kind of a thing here. We're given input ratings. We're given gas pressures, electrical information, good kind of stuff here. And of course, we have our checklist at the end. Good for us to know. I kind of like it. Good stuff. Any questions on mechanical stuff before we move into gas? We okay on mechanical so far? Pretty simple stuff, right? Nothing too crazy, right? We don't want to get too crazy on a Friday. All right, let's talk about fuel gas. Let me grab my workbook here, make sure we're all on the same page here. All right, moving on. Let's see where we're at in the workbook here as we scroll down. Yes. Okay. Hey, my bowling ball doesn't show up in the workbook. How come? I didn't think that would fly either, you know. Kind of like my bowling ball. All right, here we go. Gas. When we look at our workbook, ladies and gentlemen, we are going to cover 3 main tasks here. Number 1, we're going to look at the installation inspection for the appliance and the equipment. Number 2, we're going to look at and understand that there are several different gas piping materials that you could choose from. I'm a firm believer, I don't know about you, and I don't know how you run your building departments, but I'm a firm believer in give me some kind of a description of what you're putting in for review and approval, and we will issue a permit accordingly. I would like to review the type of gas system, the pressure of the system, the materials you're using, and the appliances that you're going to be hooking up to the gas piping system. Is that too much to ask? What do you think? Is that too much to ask?
According to my customers, it's way overboard.
Yes. So, Jamie, I'm going to ask you, when you send your inspectors out there, what the heck are they looking at? Are they taking the whole code book out there and inspecting off the code, or are they designers out there?
Nope, they're taking what I process and approve for them to look at.
Say that again?
They're referring normally, unless it's just something that you don't have plans for, but normally they're looking at the approved plans that we process and or approve versus what they've installed to make sure that what they've installed has indeed been vetted and approved.
And what type of construction documents do you receive in your building department for fuel gas piping systems?
So we'll get a single line drawing to make sure that they're installing the right size pipe.
Right.
Depending on what the item is, sometimes we ask for manufacturer's installation instructions because technology is ever changing and we want to make sure that the customer is installing it for the manufacturer's installation instructions as well.
Right.
Title 24 documentation maybe for the energy code.
Okay, so for fuel gas piping systems, I agree with you. You're getting some kind of a description. You're getting pipe sizes. You're getting the material that they're using as well, like CSST, Schedule 40 pipe. Is that right?
Correct.
All right, great. So we're given a description. So when your inspectors go out in the field, ladies and gentlemen, they have some kind of an approval that has been approved based upon the permit, something to go off of, right? That's called communication in the real world. You know, I tell you, makes my mind boggle. When I took over this building department here in Ohio several years ago, like over 20 years ago, our department was just kind of like an old department. We were still on paper back then, you know, everything was all paper. And it was willy-nilly, right? But as the state of ours decided to get more professional and made us take all these examinations for certification, we started to realize that what we were doing was incorrect. We wouldn't have any drawings on mechanical, electrical, plumbing, nothing like that. The only drawings that we had to receive way back was just the structural drawings for the building. And I asked my boss at the time when I first started in the building department, you know, I'm going out here doing mechanical and electrical inspections. You know, what the heck am I looking at? He said, don't worry about it. The contractors know what they're doing. Now, you know, I came from the contracting side. That's where I started. And I said, you got to be kidding me. I says, there's good contractors out there. There's no doubt about that. Fantastic contractors. But then again, there's some questionable contractors out there, right? If I see violations, I'm supposed to take the code book out there with me and try to figure out what size pipe is right and what material is right. No, that's not your job as an inspector. Well, lo and behold, I learned a lot from my boss. The guy was a great guy, took me under his wing, but you know what? Eventually he died. Guess what happened? He died, right? I was the assistant chief. I took over for the guy. You know what I did? I changed that whole darn building department around. We needed to get drawings in. You need to know what you're looking at out there. Let's talk about this. Let's understand. Let's understand the safety. Let's understand the hazards of gas piping. Let's understand the good installation of gas piping. You're given a whole bunch of code sections right here. Code requirements in chapter 24. Most sections in chapter 24. As we go on, I'm going to start out really, really easy here. When we look at a simple gas piping little diagram here, you see this right here. It's figure 21. I'm going to get into my PowerPoint. I'll make it a little bit bigger on the screen. And let's understand the routing, okay? And I'm going to ask you some really pointed questions. And if you don't have the answer, that's okay too. Here is the meter right here. This is a gas meter. The point of delivery. I'd like for somebody to look up the definition of point of delivery. Can you find that in your code book? We need to start here because the code will say you have jurisdiction from the point of delivery. Well, what is the point of delivery? For this, it's real simple. If I've got a gas meter, it's at the outlet of the gas meter. That's where our code starts, ladies and gentlemen, is at the outlet of the gas meter. From that point, all the design, the installation, and all the code requirements come from this point all the way through the gas piping system, including the fuel gas appliance connectors. What am I talking about? We take care of all the fittings, the piping, the installation of the piping, the sizing of the piping, all the way through to and including all valves, all regulators, and the appliance connectors that connect the appliance to the gas piping system. That's what's given to you in chapter 24. If you don't have a meter, ladies and gentlemen, sometimes you don't, maybe you're on a, I don't know, maybe like, I want to say a campus, but that's commercial. Maybe you're in an association where maybe for your particular unit, you just have a utility shutoff valve. Then it's taken from the outlet of the utility shutoff valve. That is your point of delivery, okay? So this is how this works. Everything from the meter in this case is regulated. Look at the routing here. We're just looking at the pipe, that's all. There's no pipe sizes, there's no material. We come down and we go across the basement. We call this the gas main, or you could call it the trunk line. I call it the gas main. We go to the most remote appliance on the gas main, which is pretty evident here. The furthest appliance outlet right here away from the point of delivery seems to be the gas clothes dryer, right? The most remote appliance. Then we come down and we say, hey, I've got a branch for my water heater. I've got a branch for my furnace, and I've got a branch off of the main for a gas log lighter. The one closest to the point of delivery is the grill here. I can make a tap off of this main right here, put a little valve here, go outside with metal pipe, and then maybe I can transition to plastic pipe. We're allowed to use plastic pipe underground only. When we emerge from the earth, it's got to transition from plastic to metal piping. We call this anodeless risers. These are devices, piping type of equipment that we use to transition from plastic polyethylene pipe to metal pipe when we emerge above ground. Okay, so that's a simple little gas piping drawing. Any plumber, any pipe fitter, any homeowner is capable of drawing a nice little cartoon picture like this, aren't they? Sure. Now ask yourself, can your inspector go out and inspect this gas piping system as it's drawing? Almost. We don't know the materials yet. We don't know if this is a medium pressure system. We don't know if it's a low pressure system. We don't know if there's regulators. We don't know if there's valves, but you know what? Inspectors can figure that out for the most part. Materials are the key here. Materials are the key. We'll talk about this. Hey, do you recognize this? I'm having a flashback. How about you? Doesn't that look familiar? We have to elevate the ignition source. I'm in chapter 24 now. Guess what I found in chapter 24? The same information that we found in chapter 13 for that oil-fired elevation above ignition source. This is for gas appliances. It reads almost exactly the same. The criteria is the same. I need at least 18 inches above the finished floor to any source of ignition. Here we got like a little pilot burner here. That may be the lowest. I need to elevate my appliance accordingly. But keep in mind, remember, this is for a water heater. Water heaters in a residential environment are so equipped, you'll find, with this flammable vapor ignition resistance system. Next time you're at Home Depot or Lowe's, go down the plumbing aisle. Take a look at it. You'll see big labels on the water heater that it is so equipped with this system. It can be mounted directly on the finished floor of the garage. Okay? Starting out basic. Where do we find this stuff? Same places we found the oil burning appliances, right? Garages, crawl spaces, attics, things of that nature. When we get into step-by-step application here, we're going to verify that the equipment and the appliances comply with the code. Particularly, we're now in chapter 24 for fuel gas. Okay. All right. Well, let me kind of talk about something here. I want you to go to the combustion air part of the workbook, and I'm going to find that for you. We need to discuss this for category 1 appliances. All right. Let me navigate here a little bit, and I don't want to miss anything here, but what I want to show you is on page 48. Turn to page 48 so I don't miss anything here. What you see here is the elevation of ignition source. What I want to point out to you is this particular picture right here. This particular picture shows a sediment trap and a gas valve right here. It's called an appliance shutoff valve. Well, I see a problem here, and I'm going to show you where this problem is when we go along in our seminar. But the gas shutoff valve, the appliance shutoff valve right here, should be above the sediment trap. In other words, the sediment trap needs to be installed downstream of the appliance shutoff. So if this is the appliance shutoff, if I shut this valve off, ladies and gentlemen, and I decided to take this sediment trap out, it's a nipple and a cap, you think I'd be getting gas out of here? If I shut this valve off and took this piece of pipe out, would I be getting gas out of that T?
Yes. Yes.
Absolutely. Yep. Absolutely. A sediment trap is to catch particles that are heavier than gas, that have maybe found their way into the gas piping system, maybe from construction. This valve needs to be up in this location here. So if I shut the valve off, if it's up here, now I can take the nipple and the cap off that we call the sediment trap to clean it out, turn the gas back on after I put it back together, and everything is fine. Okay, we'll talk about that as it comes up. All right, here's where I want to kind of start right here. It's combustion air. It's step 2 right here. We're going to talk about combustion air requirements a little bit. I want to show you how this works when we talk about fuel gas piping. So my first code section here that I want to introduce to you is this code section here. The section is 2407 in your residential code book. There are several ways to provide combustion air to category 1 appliances, right? Category 1 appliances, not category 4, category 1. Ladies and gentlemen, look what I got here. I've got a room here. I've got a room here. This is a room. It's a mechanical room. The code calls it an enclosure for gas appliances. I call it a room, not a big deal. I've got a furnace here. Furnace with a draft hood. This is a category 1 appliance. Flue gas temperatures are real hot. I need to provide combustion air for all category 1 appliances. A water heater with a draft hood, it's no different. It's a category 1 appliance. I've got a metal connector here, maybe single wall metal pipe going into a chimney or a gas vent. Same thing with the furnace. I'm connecting a metal pipe into a chimney or a gas connector. How am I going to get combustion air in here? In other words, you have a choice. You could use outside air, you can use inside air, but I caution you to use inside air because of the way we build our homes today. Maybe you can help me. Has our energy codes gotten more stricter and stricter every edition?
Absolutely.
They have, haven't they? We're tightening up our houses. Our houses do not breathe like they used to. We can't rely on air infiltration coming through all the cracks and nooks and crannies of our house to supply the volume of combustion air to mix with the gas. It's becoming impossible. Unless you do a blower door test to calculate the number of air changes per hour, maybe you can provide all air from the inside, but it's unlikely. So here's an alternative way to do this. Here's a good way to do it. You take air from the attic space and you can say that is outside air. Now, how can I take air from an attic space and consider that to be outside air? That's the first question I have. Can you do that? The answer is yes, you can, provided that the attic space is properly ventilated according to the building code. You know that, right? You check it as building plans examiners. I hope you do. Maybe you have soffit vents over here. Maybe you got a ridge vent or gable vents, right? Certain area based upon the square footage of the attic space, whether or not you have a vapor barrier, right? It's either divided by what, 150 or 300 or something like that. Something like that. But it's got to be properly ventilated. We're not going to go into that part, but if it is, I'm going to take it from the attic space. And oh, by the way, if I have a ventilated crawl space to the outside, I can actually use the crawl space as well for another opening. So I can take in outside air through the attic space, through the crawl space, or go directly out of a sidewall to the outside.
Gary,
This is what, yes,
it is
go
very-
ahead.
about the crawl space part, you know, in our state, you just gotta be careful whether you condition it or unconditioned the crawl space.
This
order
is
to
an
utilize that.
unconditioned crawl space,
Okay.
right, Francis? This is unconditioned. You see the screens here? This is vented to the outside. So your building thermal envelope would be the floor here. This would be unconditioned crawl space. That's what we're talking about. Good point, Francisco. Great. So let's look at something called a two opening method. The code comes in 6.1 and also in the commercial fuel gas code and allows you to prescriptively design a two opening method. It says, hey, I need one opening within 12 inches of the ceiling and one opening within 12 inches of the floor. That's the two opening method. And you will calculate it based upon your appliance input rating. You will add up all of the appliance input ratings in the enclosure and calculate it at 4,000 BTU per hour is equivalent to 1 square inch of opening. Don't worry about it. I have an example for you. I could have that type of an orientation. I can also have two ducts going up into an attic space. Take a look at this. Hey, let's see here. Where is it? This one right here. This one right here. So I could still have two openings here. I'll just punch two ducts up into the attic. I'll do exactly what the code told me to do. I'll have one within 12 inches of the ceiling, and I'll have a duct coming down and end it within 12 inches of the floor here. Think about
Gary?
this.
Question for you, Jerry, about
Yeah.
a sealed combustion furnace.
We're
Are
not
you gonna
talking,
cover-
we're not
are you gonna-
talking sealed combustion.
No,
This
are you
is
gonna
not,
cover that though?
pardon me?
Are you gonna cover sealed combustion furnace?
Say that again. You're breaking up a little bit, Francisco.
Are you gonna cover sealed combustion?
I will. I
Okay.
will. Not now, though. This is not sealed combustion.
All right.
We need combustion air to come in for the burner to
Yes.
mix with the gas. These are category 1. They're non-direct vent appliances. We need combustion air. Okay.
All
So
right,
we
thank
are
you.
going to bring in combustion air from the outside via the attic space. Okay. We need air to mix with the gas in the burner here to provide complete and proper combustion. The area of duct is dependent upon the input rating of the appliances, isn't it? Code says, you know what, you can design this. I say, great, show me how to do it, right? Let me find out here. Bear with me a minute here till I get the right slide up here. I had some examples put together for you. Yeah, we know that. There's the sediment trap. Let me go back to that. Bear with me a minute here. Let me get the right slide up here. I plucked in some good examples this morning for us. Let me get those up here. Oh, here it is. Yep. Two opening. There it is, right there. Okay, so our two opening method that we just looked at, I have an example here for you. So I want to provide combustion air into this mechanical room that the code calls an enclosure. How do we do it? Here's my example. If I have 150,000 BTU per hour furnace here, and I've got a water heater at 50,000 BTUs per hour, right? I need to calculate the minimum net free area. Now keep one thing in mind. There's a code section that you need to look at before you do or review any mechanical plans for combustion air. You know what that code section is? I don't know. I have to think about it. It's 2407.11. Okay. 2407.11. That tells you all about the ducts. And we're going to visit that. But it says you can never put any screening above here in the attic. This has got to be wide open duct, ladies and gentlemen. No screening, no louvers, no nothing. Wide open duct. The idea is to get it above the insulation, above the ceiling joist. One opening, two openings. So I've got the total BTUs here. Here's how we do it. Real life. I don't know. I don't live in fantasy land. Neither do you. I'll take the summation of all the appliances in the room. Here we go, right here. Add them together. It equates to 200,000 BTUs per hour. I'll do what the code says. I'll now take that total input rating, divide it by 4,000, because that equates to 1 square inch of opening I need for combustion air. I need a minimum 50 square inches for this duct and 50 square inches for this duct into the attic space to provide enough combustion air. So I say, okay, in the real world, what are some real duct sizes? You know what? You can't call up the sheet metal supply house and say, I need a 50 square inch duct. Come on, get real, right? These are common duct sizes. 14 by 4, it's going to give you a 56 square inches. So I could use a 14 by 4 here, 14 by 4 here. Hey, I'm a mechanical contractor. I just got done with the job. I got 8 by 8 duct in my truck. Can I use that? Absolutely, because you've exceeded the 50 square inches. This is the minimum area you need, ladies and gentlemen. So here's some common duct sizes. So you say to yourself, Jerry, I got some round duct. Can I use that? I got an application here. Can I use round duct? Here's an equation for you. You know, I mean, if you're a pi r squared person to calculate the area of a circle, fine. I'm not. I want diameter all day long. Here's the equation. Area equals pi times d squared divided by 4. You want to know why I picked this equation? Because I'm solving for diameter. I'll rewrite the equation and solve for diameter. Now, play along with me here. I didn't have a square root symbol, so I had to raise it to the half power. This is in a math class, but it's pretty simple. So everything in the parentheses is the square root, okay? Or if you have a scientific calculator, raise it to the half power. You'll get the same exact answer. So I take my minimum area that I calculated up here. By rewriting the equation, I'll take the square root of 50 times 4 divided by pi, and I'll come up with approximately an 8-inch round duct. That means I'll put an 8-inch round duct here and a long 8-inch round duct and end it within 1 foot of the floor. And I'll have enough combustion and volume coming through those ducts for this capacity of 200,000 BTUs per hour. Right? Okay, so when you send your inspectors out in the field on a category 1 furnace and water heater that's bound up in a room, your inspectors will now know how to calculate a 2-opening method. And then you'll hear from the builder and say, I haven't done this ever. You're the only building department that makes me do this. Well, if you've administered and enforced the code and adopted it lawfully, it's in the code. This is your point, ladies and gentlemen, to educate the constituents in your area. I've heard this like a broken record. I've dealt with the home builders both on a national level and a local level for many years. I'm a big proponent of mechanical systems and proper combustion air. So what I tell them is I say, okay, if you don't like the 2-opening method, guess what? I can save you some money, because every time, you try to change a code, of course, people get upset and say it's going to cost me a fortune to build my house. It's really not. I say, if you don't like the 2-opening method, how about a 1-opening method? I'll save you money all day long, right? Well, what's the 1-opening method? You could only use this for fuel gas appliances. And the key to this is combustion air not only provides air to mix with the gas, ladies and gentlemen, it provides a cooling effect within the room or the enclosure where the gas appliances are located. So keep that in mind. That's a secondary function of combustion air. I'm looking at a plan view right here of a mechanical room. And you could see right here that we need to have our appliance away from walls and doors. It says that right here. If you're going to use the 1-opening method like this in elevation, I can pop a duct right up into the attic space. That's considered outside air. Or I could go horizontally all the way through to maybe like an opening on the exterior wall. or have an opening here. But what you need to do is you need to make sure your appliance is set away from the walls and doors, at least right here. The opening has to commence within 12 inches of the ceiling. You cannot be any lower, okay? You need to be 1 inch away from the sides of your appliance, okay? And 6 inches away from the front of the appliance. So from the sides and the back, it's 1 inch, and from the front of the appliance, you need at least 6 inches. But you'll find that our clearance, if it's the front of the appliance, requires 30 inches, doesn't it? So we'll have that beat if that's the service side. The idea is we want to get enough air circulating around the appliance to cool the enclosure, cool the room down, right? Because we're only providing one opening. But here, look at this. It says right here, you need a free area of 1 square inch per 3,000 BTUs per hour. I say, okay, I'll add up all the BTU per hour ratings of my appliances and I'll divide by 3,000. That'll give me my area minimum of opening into the attic space. But wait a minute. There's one further thing that people may miss, and I've seen this happen before. Don't forget about your vent connectors, because the last sentence, ladies and gentlemen, says, not only do you have to calculate this area of opening, this opening area cannot be smaller than the total combined connector areas of all of the appliances in the room. I know I sound like a goofy code book, don't I? Let me show you. Can I explain this to you? Can I show you a picture?
Sure.
Can I enlighten you?
Absolutely.
All right, let me get my picture here. All right, here it is. This is your section. I just got done reading that code section to you. I don't like reading bedtime stories. I like to show you how it's done. All right, we want to calculate the minimum area right here of a one opening into the attic, saying that it's properly ventilated. I'm going to take outdoor air for combustion for my furnace and my water heater. This is the opening right here, right? We have our initial check for area here. 3,000 BTUs equates to 1 square inch of opening. Fantastic. Now we are looking at the sum of the areas of all vent connectors that must be driving this opening here. It may drive the opening to be bigger than the first calculation. Here's how this works. Let's say I've got a furnace, ladies and gentlemen, 150,000 BTU per hour gas furnace. 5 inches is my connector. Remember, a connector is the pipe that connects the appliance to the vent or the chimney. Well, this is a round 5-inch pipe. Fantastic. I got a water heater. I got a round 4-inch pipe that is a connector that connects to the vent or the chimney. You ready? Let's do the calculation. Let's check. Now, I do the first calculation that the code told me about, that 3,000 BTUs per hour equates to 1 square inch. Again, the total capacity that I have input rating in the room is 200,000 BTUs per hour. I'll take 200,000 BTUs per hour, divide it by 3,000. There's my minimum square inch opening for this opening here. My check is I need to evaluate the areas of the connectors. Here's how we do it. I take my area formula and I take the area of a 5-inch connector right here. See, I plug it in and then I add it to the area of my 4-inch connector for my water heater. I'm taking the total areas and I'm taking the summation of all of the connectors in the room, and I find that it equates to about 33 square inches. I evaluate that. I say, is that less than what I calculated up here? Less than or equal? If that's true, then I can use this value, which it is. The area of the sum of all connectors is less than what we calculated in our first equation. Therefore, we can use 67 square inches. Let me tell you where this goes kind of backwards or sideways. If this was like an 8-inch connector on my furnace and maybe a 6-inch connector on my water heater, this number would be higher than 67 square inches because of the connector area. You follow? I'm moving a volume of air through my draft hoods, through the connectors. I need to be providing an equal amount of volume in the room. You follow? So sometimes if this number gets higher than what you've calculated up here, you need to use the higher value for the opening into the attic space. Does that make sense, ladies and gentlemen? That's why we evaluate the connectors separately. Any questions?
Yeah, Jerry, Don here.
Yeah.
At some place you're going to mention it, but I couldn't find it in the book. These areas, whether it be from the foundation, crawl space, or the attic, has to be in excess to the calculations of the building code required for the attic ventilation and the crawl space ventilation, or at least that's the way it used to be. I trust that hasn't changed.
Yeah, it's got to be consistent with the building code. You'll find that probably in the code commentary, Don. It doesn't come out in the code. That's why you're not finding it in the code. You know, it's in the code commentary.
Oh, sure. So they don't put it in the code? But then how does the inspector or anything know that?
Yeah, there's a lot of things in the code that you need to go to the code commentary to get the full intent of the meaning, you know?
Yeah. Well, the contractor, that would rather explain on these newer codes why the contractors aren't doing that. And,
well, that's our job as code officials, to explain that to them, to take meetings and say, hey, listen, here it is. If I read the code commentary, it's understood that a properly ventilated attic space or a crawl space can be used as outdoor air. Yeah. Good question, Don.
Another thing I noticed too, where you indicated that there was louvers. I know throughout the country, sometimes they put louvers that you can close for the crawl spaces. We don't allow those here because people close them in our higher elevations here. Lower elevations, we don't bother with it, but they can close that off and they lose a great deal of their combustion air if they're pulling it from the crawl space.
Don, you brought up a fantastic point here. You're exactly right. If I decided to go with any type of an opening with a louver, that's going to change the amount of square inches. Unless I got a louver from the manufacturer that stated I've got a net free open area of 67 square inches. That's what you're supposed to do, is get that allowable opening so you can at least get that amount of volume of air through the louver and the screen and things of that nature. Yeah, good point, Don. Any other questions on this? Questions, comments? Okay, we got about another 10 minutes to go before lunch, I think. So let's kind of take another look at this here.
Jerry, you know what? I do have a quick question. That the connectors, the 5-inch and the 4-inch connectors,
Sure.
That's as per manufacturer's specs, or that's something else in the code?
No, this is what you would be connecting to on your appliance.
Size, yeah.
Yeah, so on the appliance, Doug, you would probably have a 5-inch furnace outlet. On the water heater for a 50,000 BTU, it would be a 4-inch outlet on top of the draft hood. And when we get into sizing these connectors, Don, I'll show you how we size the connectors as well. And they should be able to match up with what the manufacturer indicates. However, some manufacturers, like water heaters, right, may come with a 3-inch draft hood.
Yeah.
But yet when I size my connector, I may be 10 feet away and I may have a 4-inch connector that I have to adapt to. So we always measure the connector size, which is the pipe that connects to the appliance. I didn't want to complicate it, but sometimes it gets a little fuzzy. We always measure the connector size that goes to the appliance. So we'll do a couple of applications towards the end of the day, and I'll show you how this works. Fair enough? All right, good. I've got more examples for you. All right, let's move on. That was kind of interesting, you know, combustion air, good stuff. Remember I told you about this code section? Before you even take a look at sizing combustion air ducts, go to this section, 2407.11. Mark this in your code book. Should I say it again? No, I don't need to say it again. Here's a partial look at this thing here. Sometimes Contractors will come up to you and say, hey, you know what? I'm going to go with this 2 opening method, but I want to use 1 duct and cut an opening in the top and leave the bottom open. Can you do that? Answer is absolutely not. You cannot do this. See this right here? That is not acceptable for the 2 opening method. You need 2 separate ducts, ladies and gentlemen. Here it is, item number 4 of the section. Ducts shall not serve both upper and lower combustion air openings where both openings are used, right? Separation, et cetera, et cetera. So they're showing us that that orientation is not permitted. So take a look at this. This is a partial. There's a couple other items in this section as well. Keep in mind the ducts need to be galvanized steel, or there's an exception here, right? Right? Galvanized steel, we got to make sure that it complies with chapter 16. That's our duct system design or duct system chapter. However, there's the exception here, right here. We're allowed to use stud and joist spaces, right? Shall not be prohibited from conveying combustion air. That's kind of enlightening, isn't it? Right? Provided not more than 1 fire block is removed. So, you know, if we use this, you know, you got to be careful because, you know, this may conflict with the energy code if you're in an exterior wall, right? You don't want to use this in an exterior wall, right? Because now all of a sudden you don't have any insulation using the stud cavity, right? Not a good thing. So maybe in other areas in the house, you may be able to pull down from certain areas. I want you to look at this. I believe you have a picture of this in your workbook. This is called depletion of combustion air. I would like you to look in the lower right-hand corner of this picture or this section view of this house. Look at this. I've got a boiler here. It's a hot water boiler, category 1 appliance, need combustion air. I've got a water heater with a draft hood, category 1 appliance. I need combustion air to be brought in from probably the outside. Let's say I just built this house a year ago, right? Inspector missed the combustion air. Plans examiner missed it. Building official missed it. And all of a sudden you get a call from the homeowner. My furnace and my water heater is not operating properly. I called in another heating and cooling contractor and they said you need combustion air to be brought in. How could your building department have approved this and issued the certificate of occupancy for this house? You're going to kill me. I've got carbon monoxide coming in my house. Have you ever heard that before? It's all your fault because you work for the government, right? Sure you have. Sure you have, right? Well, look at what's happening here. If you get no combustion, if you think you're going to get it all from the inside of the house, ladies and gentlemen, get the calculations. Make sure you review it. Can you really? Maybe. I doubt it, though. So for a case like this, you probably want to get it from the outside. What's going to happen if you have no combustion air? I'm going to give you the scenario. Let's say you're in Cleveland, Ohio, in the middle of winter, and nobody's got their windows open. And let's say it's around the holidays, and all of a sudden it's 5 degrees Fahrenheit outside. Well, I'm going to do a load of clothes in the basement here. My dryer has an exhaust capable of exhausting 200 CFM. I've got a range hood. We're cooking dinner. Maybe it's around the holidays or something. The stove's on. I've got a range hood blowing out 100 CFM. Bathroom, 80 CFM. Perfect storm. You see what's happening here? You know what's happening in here, don't you?
Sure.
It's negative. It's going negative, man. Where am I getting the makeup air? I got no combustion air. I got no makeup air. I've got nothing. What's happening to the flames? What's happening to the combustion process in my water heater and my boiler with the draft hood? You know what's happening? The flames are starting to maybe lick out of the door here. You follow? I've run into this when I was a contractor. I've run into this all the time. If you don't have enough combustion air or makeup air, what's happening? You're getting a negative effect. You're drawing downward, right? The products of combustion are spilling over the draft hood. It's called incomplete combustion. Complete combustion, the byproducts of burning natural gas, remember, are water vapor and carbon dioxide. Incomplete combustion, where I have my flames licking out, incomplete combustion, bad fuel to air ratio, leaking out of the draft hood. Now we're introducing carbon monoxide, ladies and gentlemen, into the space. Combustion air is missing here. You see what happens here? I think it's pretty important when you got category 1 appliances. I call it out on all my plan reviews in residential. I deal with builders all the time, you know. Oh my gosh, we never heard that before. I used to hear that like 10 years ago, right? Nowadays, everybody's aware of it. But the key to this is you're using category 1 appliances. I haven't even mentioned category 4 appliances. You know, we see category 4 appliances, ladies and gentlemen, often. These are our high efficiency appliances. You know, we're allowed to vent these things with plastic pipe. They're sealed combustion chambers, right? Where I can bring all combustion air from the outside through a pipe into the appliance and then take a plastic pipe out as the exhaust, and I don't have any need to bring in combustion air at all from the outside. Those appliances are really nice. We see a lot of those. Do you see a lot of those in your jurisdictions? The category 4 appliances?
Yeah, great.
Yeah. Yeah, so that's what we deal with, you know. Category 1 appliances you need to pay attention to, you know. That's what it's all about. So, all right, what do we got here? Clearances, all right. Oh, yeah, this is the flashback here. We talked about clearance reduction. Let me cover this quickly here. We talked about clearance reduction for oil and solid fuel burning in chapter 13, but look at here. Here's that table right here in chapter 24. Write this down. 2409 is your section for clearance reduction. Here, I want to show you. You have a clearance reduction table in chapter 24 for natural gas and propane appliances. If you stay within the bounds of the table, you can provide a prescriptive assembly like we did with chapter 13. Remember, you build the wall assembly or the ceiling assembly kind of a thing, and you stand it off from the wall with a 1-inch air gap using metallic fasteners and metallic non-combustible spacers, maybe like washers or pipes, things of that nature. And we can go with the same type of an effect here. Remember, combustion air not only comes in for the air to fuel ratio, but combustion air also provides, remember, a nice cooling effect as well. However, we're not going to rely on combustion air if it's a direct vent appliance. However, we can provide a method, if the manufacturer will allow it, to reduce our clearance to get a little closer to combustible materials and surfaces. Now, here's the table in chapter 24, along with this in parentheses, right, Francisco? This is the number, section 308.2 in the commercial fuel gas code. So it's exactly the same. If you look at the table, it's exactly looks like the same that we dealt with in chapter 13. Very similar. I can go down with that assembly that I built on the wall, 2 layers of, or 2 sheets of 24 gauge sheet steel with insulation sandwiched in between. I can reduce the clearance to 12 inches with respect to this application. Same kind of a thing. So if I'm an inspector or a plans examiner or a building official and I'm writing up an order or a plan review letter or a notice of violation, I'm citing the right code section based upon the fuel of the appliance, you know, things of that nature. If I'm trying to help somebody, maybe a contractor calls me and says, hey, Jerry, the manufacturer allows a clearance reduction. I'd like to build something on the wall. I don't want to buy anything to put on the wall. I can build something. I got a sheet metal shop. You know, hey, here's the table right here. If the manufacturer allows it, you know, just shoot me a little drawing and manufacturer's instructions and let me know what you're going to build. No problem. I'll approve it and I'll issue a permit. You know, that's how we do it. Your inspectors got it easy when they hit the job site then, you know. Francisco, I think you asked me about the sealed combustion chamber. You did, didn't you? This is a sealed combustion chamber, okay? This could very well be a category 1 appliance if we use a pipe and pipe type system. These are metal pipes here. However, this is a sealed combustion chamber. Look what happens. This is my combustion chamber that's sealed up. This is a 2-pipe system, ladies and gentlemen. I take in combustion air from the outer pipe into the combustion chamber. This is a special metal pipe system. It goes through the heat exchanger, my products of combustion, and now it vents straight out through the middle pipe here, through the termination cap to the outside. You could see it takes all air from the outside into the combustion chamber. I do not need combustion air drawn in from the outside for this particular appliance. It draws all combustion air from the outside. All right. I put this code section down. Write this code section down here, or go highlight this. This is for your category 2, category 3, and category 4 appliances. Okay, this is very important here that you look at this. All right. Category 2, 3, and 4, right here. The design and installation of vents for these appliances are in accordance with the manufacturer's installation instructions. And it's that easy. Your mechanical code, or chapter 24, will give you prescriptive venting and sizing requirements for only category 1 appliances that we just got done talking about that rely on combustion air. You know what I'm talking about? All the other categories, you'll follow the manufacturer's installation instructions. All right. One further thing, and then we're going to go take our lunch break after I ask for questions, is this. This is brand new for 2018, right here. So this is called through the wall direct vent termination clearances. As an inspector, you're going to look where these terminations occur. You see this right here? Can I terminate near any windows or doors? Well, you're going to look at the input rating of the appliance first in the left-hand column, and then you're going to look at your terminal clearance from any building opening, like a wall, like a window or a door, things of that nature. As you can see, as your input rating ramps up, your distance gets further and further from the termination point. When you get into over 150,000 BTUs, now you're looking at the manufacturer's installation instructions for those particular clearances. And again, these are direct vent appliances accordingly. And if you look at the commercial fuel gas code, you're into section 503.8. All right, I'm about out of breath. Any questions on mechanical, on this little bit of venting or combustion air? Any questions?
So Jerry, this table you're showing now, this is only fuel gas, correct?
This is fuel gas, yes. Chapter 24, yeah. Fuel gas.
Is there a similar table for direct vent that's not fuel gas? Is there such a thing?
It would be in chapter 13. I don't know what the code section is, but there should be something in there. Chapter 13. All right. I'll tell you what, if you go to chapter 13, what you'll probably find is maybe a reference to NFPA 31, because NFPA 31 has venting requirements, Doug, for oil-fired appliances. That's probably where you're going to find it at. Okay.
Huh.
All right. Any other questions? Questions. All right. So hearing none, all in favor of taking lunch, signify by